Okay, we're going to practice simplifying polynomials. So this goes back to junior high. Junior high, you may have used algebra tiles. We don't tend to use them much in high school, but I wanted to put them on here so in case that you did like using them in junior high, you had sort of a reference. But we don't end up using the physical ones, but you can kind of think back if you need to. You can ask your teacher if you really want to have them, but you need to get to the point where you do not need algebra tiles to simplify, especially if you're going into 10C. So reminders, if we're, depends on the set, but usually a green or a color is positive. The rectangular ones are positive x. The little square is positive 1, and the big square is positive x squared. So basically this green rectangle has the same length as each side there. And then if it's white, it's negative. So to simplify a polynomial means to collect all like terms. So if you're dealing with algebra tiles, you can only collect the ones that are the same shape. So then you add and subtract the coefficients of the like terms only. So it says in question 1, algebra tiles are shown below to represent the polynomial. So here, all of these terms are there. So there's your 2x squared, the big green squares. Then 5 negative, white, which means negative, x's, plus 2 minus 3x squared plus 2x plus 4. Okay, so group the like terms and remove 0 pairs. So remember, a color and a white together gives you 0. So for the same shape. Okay, so I can actually do this. Oh, maybe I can't. No, I guess I can't. So here we're just going to mark them off. So this and this one add to 0. This and this one add to 0. Okay, then one of these and one of these, one of these and one of these, and that's it. Those are the 0 pairs. So what's left is, I'm going to start with any x squareds because that's the highest degree. I'm just going to change this to, so here the only big square is this white one, so that's negative x squared. Then my x's, what I'm left with are these 3, so that's negative 3, so it's subtract 3x. And then I've got a bunch of little ones, so 1, 2, 3, 4, 5, 6. So plus 6. Okay. And that's what we're going to do. So again, you can use algebra tiles, but it is kind of time consuming to set that up. Really what we're doing, if you take a look, 2 minus 3 is negative 1. Negative 5 plus 2 is negative 3. And 2 plus 4 is 6. Just collecting like terms. So that's what we're going to do here. So you might want to circle any like terms. So the m's are like terms and the numbers are like terms. So we'll put the m's first, higher degree. 5 plus 10 is 15 m. And 8 minus 10 is negative 2. So it's subtract 2. All right. Next one, x squared and an x squared. Actually, I'll include the sign in front. Then an x term and an x term, and a number term and a number term. So x squared terms first. 5 plus 4 is 9. And then x terms, 8 plus 3 is 11. And 10 minus 2 is 8. Okay. Next. So here, m squared and m squared. Circle the sign in front. M and number and number. So 2, remember if there's no number it means a 1. So 2 minus 1 is 1. And we don't have to show the 1. So it's just m squared. Positive 12m plus 3m is 15m. And then 1 minus 4 is negative 3, so minus 3. Next one, 5x squared plus 2x squared. We've got an xy and an xy. That's different from a y term. So that y term doesn't have anything that's like. So I'm actually just going to erase that. But neither does the x. Okay? And neither does the 3. So sometimes there aren't any like terms to add. So we'll do the x squared. Notice how that's a degree 2. xy is a degree 2 as well. But we're going to put the x squared first. Think about alphabetical order, right? So put all the x's, it's earlier in the alphabet. Then the xy, 8xy minus 2xy is 6xy. Then I'm going to go alphabetical order. Then I'm going to go minus 3x, because these are now degree 1, plus 4y, and then the constant term at the end. Okay. Next, mn with mn, m squared, and m. So really, there's only two terms that are like terms. In terms of what to go first, these m squared and mn are both degree 2. Again, we like to have the term that has just the earlier letter in the alphabet. Okay, so I'm going to put the 8m squared first, then I'm going to put the 15mn. Now, if you switch those around, I'm not going to take marks off, right, because they're both degree 2. And then the minus 10m. So remember, those terms have to have exactly the same variables, otherwise you can't add them. So I'm done, right? You can't collect anything more there. Next one, we've got 2m squared minus 6m squared. So it's almost like a matching game, right? Now take a look at this one. I think I made an error, right? I've got actually m times m there. So technically that's an m squared. I probably meant to put mn, but anyway, there it is. And then I may have fixed it on your note sheet actually. So take a look. It might be slightly different if I did fix it. I can't remember. So those are like, then there's nothing with this. There is a constant with this one. Okay, so 2m squared minus 6m squared, and again, we're assuming this is 3m squared. So plus 3m squared is negative 1m squared. We don't have to show the 1. And then I'll do the mn term. Then I'll do the m term, so alphabetical for degree 1. And then the n term. And then the constant. 12 minus 3 is 9. Okay. And then what do we have here? Negative x squared minus 5x squared. We've got an x term and an x term, and a y squared and a y squared. So I'll start with x. So negative 1 minus 5 is negative 6. Again, we have to get the degree 2, so then I'm going to do my y squareds. So 8 plus 6 is 14. And then my x terms would be negative 9 plus 2 is negative 7, so subtract 7x. All right. And then the last one here, write an expression for the perimeter of each figure. So remember, perimeter means you add up all the sides. Take a look here. There, you don't know all the sides, but you're given some information. Those dashes mean this is going to be 3x cubed as well. And double dash means this is going to be 5x. So you're going to have perimeter equals, and you just start writing them out. 4x cubed plus 5x plus 3x cubed plus 3x squared. Now you could double the 3x squared, cubed I should say, but I'm just going to show all of the terms. So there's 5 sides. It's a pentagon. So we have 5 terms there. Sorry, and so I'm going to maybe switch to red. So I've got 4x cubed and a plus 3x cubed and plus another 3x cubed and then an x and an x. Okay, cubed terms first. 4 plus 3 plus 3, that's going to be 10. 5 plus 5 is 10 as well. 10x cubed plus 10x, can't do anything more than that. Over here, perimeter. Okay, so there's 2 terms on each side, but that's okay. We're just adding everything together. So plus, and you could put brackets around it if you wanted to, but because you're adding, it's not going to change any signs. We're going to talk about adding and subtracting tomorrow. But for adding, nothing changes when you get rid of these signs. I've run out of space, so I'm going to go down here. Okay, oops, a little crazy with my brackets. All right, so each of those has a p term. So 10p plus 3p plus 3p plus 2p. So 6, 8, that's 18. Oops. P, and then they all have a constant. -1 plus 4 is 3, plus 2 is 5, plus 2 is 7. Okay, and that is collecting like terms.